So it's Saturday, I've done a wedding today, so that's about me worn out. It takes a lot of doing now. Bought this off eBay about a year ago, probably 2 years ago. With the COVID, I've lost all track of time. Top band transmitter. So top band is 1.8 megs, and at the time, certainly when I did my radio amateurs examination in 1979, you were only allowed 10 watts on top band. I think it was showing that with shipping in those days. And this one is clearly AM or CW, CW meaning continuous wave or Morse. Now, if you saw any of our videos of the 10 metre club night from my van, they want one of the bands they want to try and have a go with. We've done top, but I think we've done most bands. We've done 40 meters, 80 meters, 20 meters, SSB, and you know, people were having to do 50 watts to get 8 miles. It was ridiculous. So that's why it's worked quite well with FM on 10 meters. But one thing none of us have tried, and I've never even been on, is top band. So you're on medium wave effectively. So I bought this. I don't know whether it's standalone. So with AM, however many watts output this is, probably 10, you'll need 10 watts of audio to modulate it. Now, a lot of AM transmitters, the modulator is separate. And a lot of AM transmitters of this era, it says 1962 when this bloke built it, G3RIT, would need a separate power supply as well. So I have no idea as to whether this is standalone and it's just going to work or not work, or whether we need a separate modulator and a separate power supply. This is why we're going to explore it. We are building, you saw us doing the PW Dart about 4 years ago, and because of the building work here, which was going to happen and now is happening, you know, things are put away, and I just don't have the bench space to do projects. So whilst Mr. Chip is away this weekend, we'll have a quick look at this. So what do we have to do? I don't know whether this is commercial or whether it's very, very well made homebrew. It's borrow one of these screwdrivers. In fact, these cutouts are rounded corners. It's not something most people would be able to do themselves, so I don't know. So we have never looked at this. I think it was somewhere Lancashire way or something that I got Mr. Chippy to go and pick it up at the time. That's a pushing screw which doesn't help. I'll be defeated getting into the case. It's got to be commercial, hasn't it? Surely. It's so well made. But then, you know, G3 RIT could well have been a professional engineer, as we are. But this does look commercial. It's going to be fun to power up. I don't think this was, you know, free. It was probably £50 or something like that. But you see, you've got, yeah, you're going to have got a mains transformer, a mains choke, and a modulation transformer. So we now can see that this is this has got the modulation department built into it, so it's probably push-pull. Let's see what's under here. ECC 83. That's preamplifier then. So what have we got there? Is it those Brimar ones? 6AU6. So that could be the modulation. I don't know the Brimar numbering, brought up on Mullard. And any American people there, you know, our valve system in Europe, you know, I've just said ECC, well, E 6.3 volt heater, C is triode, C is triode, 8 is B9A base. So, you know, the numbering builds up what it is. So EZ80 would be a rectifier with a 6.3 volt heater with a B9A base. So when we come to numbers with 6AQ6, I haven't got the foggiest, or is it 6AQ5? But that looks to me like they are probably record player type, television type, audio amplifier valves, and in this instance used in push-pull. And I would think that in push-pull it's going to be somewhere around 12 watts possibility. I would think single-ended there'd be maximum of 4 watts, but these can all be looked up. So what else have we got? That looks like a diode. BW6. So this is the way it's been manufactured. Looks like they used Brimar valves, and I'm glad to see Brimar are back in the business. They've bought equipment from another country, and like Romania or somewhere like that, and it's coming back to the UK and being assembled here to make valves. So looks like that's going to be the rectifier valve, because we've got the mains transformer there, and see what that is. It's a Mullard, so it's EZ80. Do you know, I just gave you that daft example I plucked out of thin air, and I said EZ80. Well, here's EZ81, so we know that's a rectifier. So if you had P series valves, they would normally be in television sets, and they'd be in a series string of heaters, and it'd be 300 milliamp heaters. If you get U series valves, you find them in domestic valve radios with live chassis technique, so they're all series strung, and there'd be 100 milliamp heater chain. D series valves are usually 1.5 volt heaters, and you know, this is, I learnt all this stuff. You do all the exams. I mean, my biggest waste of time was learning about CPUs in mecha control systems for video recorders. I think I did 3 years at night school to learn about these mecha control systems in video recorders, and I don't think I ever had a mecha con fault in a video recorder. And of course now all that is total waste of time. I've probably thrown away all the manuals now. Spent thousands of pounds learning about it, and to what? So we've got a Bellingly socket that goes nowhere. We've got mains input there, so that's a bulging power connector socket. It's a small type. I haven't got the plugs for that. So what's this going to do? I don't know. Screened, so is that going to be microphone input? I really don't know. So we've got two aerial sockets, or what look like aerial sockets. I don't know. You know, if I knew what this was built around, perhaps somebody recognises it and say to me, hey, this is the radio and electronics constructor project for such and such a month in a magazine. It's probably a magazine project. So I mean, what have we got in the UK? We've got Practical Wireless, we've got Radio and Electronics Constructor at that time, or was it just called Radio Constructor? We've got Shortwave Magazine, and of course we've got the RSGB Bulletin as it was, which is now Radcom. So what is it? I don't know. Gardner transformers. We've got this other transformer here, haven't we? Or is that the choke? So we're going to power this up. And it says power, it says key. Oh, and it says mic. So I don't know what the sockets are on the back. One's going to be aerial, isn't it? It's as if that was once aerial and it isn't now. So we've got two aerial sockets in that case, so how's it wired? I don't know. Well, that's on a coaxial cable. I wonder if it puts the aerial through to receive, because it's on this rotary switch. So I wonder if your receiver is connected to one of these, and when you're in the standby position, it's back to, that's going to be transmit, isn't it, the rotary switch. So you're going to turn it to the left to go into AM, or to the right to go into Morse. So anyway, it looks like it's self-contained. It looks like the power supply is in there. We've found the rectifier, we've found the mains transformer. I mean, there's got to be 200 quid worth of transformers easily. I mean, I just had a transformer made. I don't know whether I showed you the we've got the Heath kit. What was it? Transmitter, the first one they did, 81, and I bought it incomplete with no mains transformer. I've actually had this mains transformer custom made. Now this is twice the size of the one that would have originally been in that unit. This is going to have to be in a separate box. But, you know, when you're making them one-off at a transformer factory, they're not going to be able to make it as compact as what Heathkit is, and this is probably overrated anyway. So that's going to have to go in a separate box, but I've had that transformer made, I think it was £120. So, you know, it's going to be an interesting video. And that's a Morse only transmitter. So what I'm going to do is I'm going to have to solder a bit of a mains lead as a temporary lash up. These bulging plugs I'm going to have to, I don't think we've got any, but it's probably something I can pick up off eBay, because they're used on these. A soldering iron, get it in the camera view, has these 3-pin bulging plugs, and you know what? That's exactly what fits in the back. You know what I'm thinking? You know what I'm thinking, don't you? Yeah. Have we got a soldering iron we can borrow the plug off? And I bet we have. I'm going to pause the video. Okay, so I've ordered a plug in the hope that this is eventually going to work. I've soldered a mains lead onto the back of the connector for now, and I'm not going to run this through a variac. I'm not going to run it through a current limiting light bulb. We'll plug it in. This bench is well protected by numerous circuit breakers. This is working on mains transformer, so there's nothing, it's not a light, it's an earth chassis on this. So I'm going to plug it in right now. Because I'm in UK, sockets have switches on them. I'm assuming it is down for on, but it may not be. So let's see what happens when I switch it on. Okay, so we'll switch it on. And I'll switch it off again. because I'm just going to put my finger on one or two parts to make sure that could have got some warmth to it. Switch it on for another 5 seconds. The filter capacitor, that yellow filter capacitor down there, has got some warmth to it. Put it on for another 10 seconds. Of course, it's just come out of a shed, it's probably been warm in there all day. So if we'll turn it off. That would be enough for the valves to warm up. I mean, the fact that valves light, it means absolutely nothing. How long have I been in electronics? Since '78, and I was messing with tellies before then. And I think in all my years, I've only come across 3 valves with open circuit heaters. So I'll take the bench light off. And I'll also take the room light off. So I can see the rectifier lit. I can see the 2 audio valves lit. The VFO valves are lit. Yeah, I'm not looking under the cans. So I think that is that's powered up fine. So we're going to have to find a dummy load, aren't we? And it's only going to be 10 watts, so it's not too difficult to find a dummy load for that. So what I'm going to do is we will pause the video and see what happens. I'll go and get a Morse key as well. So we'll start setting up the equipment, and there's a snag straight away. This thing has got Belling lead connectors, and we haven't got anything to do with Belling lead connectors. We've got to make something or get an adapter or something. So what I've got here, I've got my Morse key, which is I mounted on a nice piece of oak. We've got my MFJ 300 watt dummy load. I think it's 300 watts for 1 second. So that'll certainly do 10 watts. And we've got my Trio power and wattsy meter, which is 1.8 to 200 megs. I made sure that's labelled. And when we bought this, we got it from RS Components, so we were assured of quality. So it's got the RS stock number as well on it. Dread to think what these would cost now, but I think it was, do you know what? I think it was $89.99 about 1980. So I'll put that somewhere. Put that somewhere so we can see it. Move that back a bit. Put that there. So we want that on. We'll have that on the 25 watt range, and we're going to be looking at forward. And I'll just make sure which one we're in. So we're on antenna 1. So antenna 1 is the in position. Now we haven't got, as I say, anything. I'm going to have to crocodile clip this, and before you all throw your hands up in horror, remember this is medium wave, so you're talking about very, very long aerials. So the SWR mismatch with having a bit of wire isn't going to really bother it, especially for just seeing whether it does anything. Now I don't know which is the antenna connection and which is the, I'll switch it off for a moment, and which is the receiver connection. I wonder if we can buzz those through with a multimeter, and when it's in, I don't know, I'm really, without a circuit, don't know what I'm doing. Move that back a moment. Right, so if I put inner to inner, I would think we'll get continuity if I'm right about it being a receive socket. Yeah. Well, it was a moment ago. Mr. Chippy's very expensive analog meter, they're about £150. Another thing that came from RS. There's just times you need an analog meter, and this is a expensive Kairitsu. Current model, right, continuity. So we'll try it that way. So if I change the switch with a pair of pliers to a different position, yeah. So that is what they are. But how do we tell which one's the receiver and which one is the transmitter? It's not labelled. Well, we're going to guess, aren't we? That's all we're going to do. Better do it from underneath. Right. What a bodge. So this time we'll switch it back on. We'll plug the Morse key in. That's labelled key. I've got one of those Rama 250FC CB type little frequency counters and the power meter and that, and I thought of dragging that out, but blow me, they don't go under 3.5 megs, so I had to get this posh trio meter out. We could get a frequency counter out if we were bothered. So if I press the net switch, ooh, net's on. That wasn't ideal, was it? So if we switch this to CW with the pliers, we're now in CW mode. Now what happens when I press the net switch? Nothing. What happens when I press the transmit switches in the key? Whoa. That was a massive deflection there. Let's turn down the drive. How do we do that? I don't know. With crocodile clip over to the left hand connector, and I wasn't getting anything on the meter, and now I've put the key down again. We are getting a deflection on the meter. I put it into calibrate. Right. So we are on the correct socket. I will just prove that by going back over to the other socket. Nothing. So it's the left hand socket, which is the one with the thinner coax, just in case you wouldn't believe that. So keying up, and we're getting a deflection. Now how can I tune this quickly? Okay, well that's us in net mode. So what happens now when I go out of net and into forward power? So if this was in 25 watts, and bearing in mind of course I've got this lash up, if this is 25 watts full scale, well let's go to 5 watts because it's less than that. It's more than 5 watts. So if 25 watts full scale deflection, let's have a look. Key it up. It's about 7.5 watts. So that's fair enough. So actually it looks like it works. I don't think we've got a frequency counter in here because so there's a lot of stuff packed away. And I can't get this on the bench in the electronics workshop for radios because of you know, there's other stuff on the bench. But I just thought I'd get this on here. Well, it looks like it works. So as far as the microphone goes, your microphone would go into the socket just there where it says mic, so it's Belling-Lee connector again. There's no reason to change any of these connectors. We'll make adapters up so this isn't spoilt because it's been beautifully made. And it's not like it's push to talk mic. It's going to be a high impedance 50,000 ohm mic, like a crystal insert type of microphone. And we can use one of those Pi stand mics, you know, like you get in taxi bass of a bygone era. You've probably seen it on one of those on our Pi base station, which I use on 4 meters AM. So we can use one of those microphones, which is high impedance. And because it being valve, that's what it would be, because it'd be something like 0.8 of a volt output from the insert, not something like 4 millivolts from a modern dynamic microphone. You'd have to have a preamp. So anyway, it looks to me like it works. So just before we finish this session, I'll just see if I can find a frequency counter just to see if we're doing something near the 1.8 megs that it says. But I've got a sticky meter there because we're getting full scale deflection. I don't know why we're getting full scale deflection apart from through my lash up. But nothing seems to have overheated. I've keep touching these. That capacitor's slightly warm, but I've no reason to believe this is now malfunctioning at all. So it looks like we've got a winner. So I'm going to pause the video, just see if we can find a frequency counter. So I had a bit of a brainwave. We've got the portable oscilloscope here. So I'm not touching the aerial leads. What I've done is just to put both the earth and the hot onto the insulation of those jumper wires which go to my SWR meter here, and if I key up, the oscilloscope shows, or it did do a minute ago, oh, the earth's come off. 1.89 megs. So if we turn that dial slightly, turn it to 1.9, key up again, .89. Let's go backwards, key up again, 1.5 something. So yeah, it's working. Obviously we'll use that with the frequency counter because it's going to be spot on. So I'm very pleased. If we'd got a receiver, I'd have been able to see what it sounds like, but you know what, I don't think I've even got a shortwave radio that would pick that up. I did restore a realistic DX160, and that no doubt will do it, but it's in storage, so that doesn't matter. Yeah, I think it's all working, and we'll have a go with a microphone in due course. So I thought, while Mr. Chippy's away, I'll turn this off now. We'll have a little play. So I'll just disconnect those crocodile clips. I mean, this might have been in use right up to a couple of years ago. Perhaps the gentleman's passed away, and you know, this is what they call a silent key sale. So yeah. Oh, come on, get these clips off. Put them back before Mr. Chippy comes back and notices them missing. So there you go. I'll put it back. And we'll move the camera onto it so we can see. As you can see, the right hand meter's tending to stick at the end. I'll have to tap that, and that's annoying because you know it's you're needing that. And there's modulation level, which effectively is the power when you're in AM. So nice purchase, and whatever was wrong with it would have been fixable anyway, but it would help. So if anyone recognises that circuit with those two Brimar, let's just put this camcorder back right. Which uses 6AQ 5 valves. A 7-pin. It's AQ5 for a modulator. Interesting. So there you have it. Somebody else's homebrew top band transmitter, and apparently it looks like it's working. Thanks for watching.